slide. In fact, my name's Alan Winnery from the University of Hawaii System, and I'm going to talk about campus networking in the post-IPv4 exhaustion world. So there's an SSID in the room from that Aruba AP, which is the same network as I use in my cubicle at home. And it's a V6 only network, meaning that the clients only get V6 connectivity to the internet. And even though they have local wire IPv4 addresses, any IPv4 address that appears on the wire is, or any IPv4 traffic that appears on the wire is translated to V6 and sent to a NAT64. Then it's running DNS64 and 464xlate as a means of providing IPv4 as a service. And it's meant to demonstrate IPv6 actually doing something useful. But I did, as I said, I bet you didn't see that coming. It kind of is a V6 talk, so you're welcome to leave, but I think you will find that it is impossible. There's no way to clear a room like giving an V6 talk these days. But for the sake of the title, in the post-IPv4 exhaustion world, things are cinching down and people are making choices. And it's a brave new world. And the stuff in parentheticals is generally the other voices in my head. But if you don't know what Huxley-esque means, you either didn't go to a US high school or you didn't read the literature. Right now, the IPv4 address supply from RIRs has run out. You can go be on a long waiting list if you qualify to get addresses. You can seek to buy something from someone who has too many addresses. But even if you buy them, that does not mean that you qualify to use them. There are industries springing to life for which revenue depends on the perpetuation of IPv4, such as IPv4 brokers and carrier-grade NAT vendors. And there is a stake in prolonging the V4 internet for some people. I'm not going to take that out too many more levels of extrapolation. And at the same time, bring your own device and Internet of Things and bring your own thing. As I just coined that because I realized I used to think of Internet of Things as the canonical refrigerator and washing machine and all that stuff that we talk about but never really comes to pass. But there are more and more devices that people carry around that when they design them, they say, hey, we'll just put Wi-Fi in this thing, right? And it'll, like I have a camera now, my Osmo camera talks to a smartphone with its own SSID, but that adds to RF space congestion, as does Bluetooth everywhere. But anyway, the corpus is growing, corpus meaning the number of addresses you need to have alive at a given moment. So in 2017, independently from my deciding to do this talk, in fact, shortly after my deciding to do this talk, the North American IPv6 Summit consensus seems to be that dual stack has run its course. The dress rehearsal is over, and it's time to start figuring out how to use IPv6 to solve real problems. So, and the form of that is IPv6 only networks. So your options going forward, if you need more addressing, you can buy more IPv4 space. It will undoubtedly appreciate financially for a few years and then depreciate. You can exhaust it and buy more. And of course, as you go forward, they'll get cheaper at a certain point, which will be a great moment. But of course, the reason they'll get cheaper is because nobody wants them anymore. And I don't know why I put that in there, but it just struck me the other day that it's not that long ago that I thought of a /16, aka a /B or a class B in the old world, as being inexhaustible. You just look at 65,000 addresses. That's just so many addresses, right? Not anymore. You can build bigger and bigger V4 NAT networks. You can support growth in NAT going forward. On the pro side, NAT in any form makes more efficient use of real IPv addresses, IPv anything addresses, than a per device assignment on the order of 64,000 active flows per NAT pool address at a given time. versus per device, which initiates between 0.2 and 10 flows per second and keeps active flows on the order of dozens at a time instead of thousands at a time. So going forward, as long as v4 persists, natting it is more efficient than putting it on interfaces. So, and then the last thing that you can do, there may be others, but is build IPv6 only networks and provide IPv4 as a service. So if you're doing IPv4 only NAT, and a lot of people are, when you do regular NAT or carrier grade NAT, you assign clients non-global addresses. You place real global addresses in the NAT pool where they can handle about 64,000 flows each. As your number of devices grows, your NAT pool gets more use and the edges towards needing more real addresses. And there's also no exit strategy for the big NAT scenario. You're not leading to a point where you can start to not need it anymore. If you just build bigger and bigger NAT, and you do reach the point where you say, you know, IPv6 is the next step for us, you're going to find that it's a big forklift upgrade, and you got to tear it all out by the roots. So with CGN specifically, not single layer or single stage v4 NAT, end user functionality, user experience are negatively affected, and the identity of users gets confusing. So kind of what I'm selling and what's on the v4, the IPv6 solutions SSID, is you assign real IPv6 addresses to clients, you assign RFC 1918 addresses to clients. Any local v4 traffic is translated on the wire to v6 and sent to the NAT64. So you don't need a v4 network anymore. You don't need a dual stack network anymore because you're shipping your v4 inside v6, or as v6, I should say. And it's looking like an increasing number of devices, OSs, can exclude this step. I got a line on another slide about that, so we'll just let it lay for now. You place real IPv4 addresses in a NAT64 IPv4 pool, and the load on these addresses increases with the number of devices, just like regular v4 NAT, but it also declines as more content becomes available in IPv6. So the way to mitigate address requirement growth is to use more IPv6. So this is a picture of a diagram of the network. It's kind of metaphorical, but the point being that the cloud is where the users are, and that AP is building a GRE tunnel to Hawaii, but this isn't shown on the diagram. But the yellow things are the things that you add to your v6 only network and able to provide IPv4 as a service. So yellow thing number one, upper left, is DNS64, and that takes, what it does is it gets DNS for an A record, and if it's serving a v6 only network, obviously the A record isn't going to do anybody any good. So you map it into a v6 quad A record, and then you hand it to the client, and then that drives traffic to the NAT64, which can take those incoming packets and translate them through the v4 pool into the internet. Then the 464X late, actually technically it's a client LAT, which sits on the wire, and then any v4 traffic that comes is drawn into it, and then it just translates that to v4 and sends it to the NAT64. So the IPv6 solutions name is because it was configured for the IPv6 solutions tutorials last Sunday. And the idea is that what if, after all this time, IPv6 has actually started solving problems? Seriously, the DNS64, NAT64, and 464X late conglomeration is complicated, but it's not at all intertwined. Each of those things is modular and separable and separated. DNS64 drives traffic to NAT64. If you take away the DNS64 and just do DNS, all the traffic will flow through the 464X late, the v4 to v6 translation of the NAT64. you could easily add more redundant DNS 6.4 because you add more name servers and advertise them. And you can also cluster NAT 6.4 without a rebuild of the network. Or since NAT 6.4 lives as you route to it across the network, it's not in front of your users, it's not in line, then you can easily turn off your NAT 6.4 and build a regional at your regional POP, or engage an IPv4 as a service vendor, of which I believe there are one worldwide right now, without changing clients or client addresses, probably without frustrating clients very much at all if you time it right. So NAT 6.4 is NAT that shrinks rather than NAT that grows. It's better than NAT 4.4 for various reasons. One is that it begins as an enhancement to a v6 network. The more IPv6 grows, the less NAT you have to do. Promoting native IPv6 reduces the use of NAT v4 address port space. So the device number growth will work one way, and the more v6 usage will work the other way. It's better than dual stack because the more you shift to IPv6 only networking, the less you spend precious IPv4 addresses on building an IPv4 network. It also doesn't require you to put up protocols in tandem and use double router memory everywhere and double configuration memory everywhere. As IPv4 addresses become more expensive and more scarce, providing native IPv4 addresses per interface assignments becomes unthinkable. Laugh now, but someday. So manufacturer support, you might ask, so who's out there that's selling boxes that do this? Well, it's actually pretty well supported across the community. Cisco has an iOS XE NAT 6.4 on certain routing platforms. We have it running on an ASR 1001. Cisco ASA has a NAT 6.4 which includes DNS 6.4 in the package. So if you're running a firewall network, you can incorporate this into your Cisco appliance. Juniper routers, Juniper security appliances, same thing. It might be that SRX does the DNS 6.4 as well. I didn't get that into the slide. I have Microsoft Forefront Unified Access Gateway, but I'm afraid I'm kind of not very Microsoft savvy, and that might be an old designator. But Microsoft is really carrying the ball in terms of keeping it in the server hardware. Palo Alto, A10, F5, and this list is incomplete. This is just what happened to pass before my eyes. And what I'm using today on this SSID is a thing called Joule, which is it's a product of the Mexico NIC and Tecnológico de Monterrey. I didn't actually anticipate having to pronounce that. Everybody read this slide now. It uses two Linux kernel modules, one for stateful, one for stateless SIT. It essentially kidnaps packets from the net filter chain and then it puts them back in later. It comes with user space programs to manage the modules and turn things on and off and manage the logging, etc. And then there's also Joule D, which runs a redundancy clustering kind of a function. You can do Joule. The kernel modules will log translations, so you have a paper trail for who did what on the network and accounting and tracking. So, as I said, it is the NAT 64 and SIT engine for IPv6 solutions SSID, and both boxes are running at nominally 0% CPU load. We mentioned it earlier in the day. Dale come up and announced it. So some people have been on it during the day today, and there's no load on either box. So another interesting, Linux-based option is VPP, which is I believe it's a Cisco derivative Linux router thing that's at that URL. And it includes stateful NAT 6.4, so it might be worth playing with. I looked at other Linux routers such as Vios, and I did not find their NAT 64 page, so NAT 6.4 page. You're not supposed to say NAT 64, but I don't care. So DNS 6.4 enables v6 only clients to access v4 only resources through a NAT64 by returning v6 addresses and quad A answers with the NAT64's translation prefix prepended on the target's v4 address. It tends to push more flows toward IPv6, and there are various ways you can tweak it. You can run it on your regular name server, and you can tell it to do DNS64 for some block of addresses, and it'll only do DNS64 for them and leave the rest alone. So it comes as a feature in Bind, Infoblox, PowerDNS, Microsoft DNS, and others. And also the combo is shown on the manufacturer slides a couple slides ago. Also, if you just want to set up a NAT64 and mess around with it, one of the easiest ways to get started is to use the Google public DNS64. And the only thing about that is that you're stuck with the well-known NAT64 prefix, which is not really that limiting. You can't route it across, well, you can route it across ASs, but you would have to set that up. 464X8 CLAT via CIT. We don't have time to explain all that, but picks up stray literals and or v4 resolver preferences. So if you've got Windows 7 on the wire or just a happiness-oriented browser, it might occasionally choose to use the A record even though it has a quad A record on its v6 network, especially if I'm providing it with v4 addresses. So there's going to be some of that. Many common OSs are doing this, and you don't need that box I showed you on the diagram. Mac OS, iOS, Apple iOS, Android, maybe Windows 10. It's very fuzzy. The most recent creators update may or may not support that. But for instance, my Android phone, if you don't have the 464X8 on the wire, it will just figure out that it's doing NAT64, and it'll handle the v4 literals inside the phone for you. And then it'll fall on the floor. I knew I was going to do that. At least it didn't ring. How many pages did I? Okay. So also, I want to make the point that you say content available over v6. You got to be up to date on what that is exactly. So if you go on the wire, and we did this in the tutorial, on the wire with v6 only, no DNS64, just a v6 name server, and you see what you can access. You find out that CNN, Netflix, YouTube, Fox News, Al Jazeera, Google, which is a big one, Yahoo, Wikipedia, XKCD, and the ACM, which that first group pretty much encompasses everything I ever browse. And then all the RIRs, of course, and all of the typical, national research networks and CSIRO and NSF and et cetera, et cetera. And so, and one day, and Apple, Microsoft, Cleveland.com, yay Cleveland, Applebee's.com popped up because I was typing in Apple, I was checking apple.com, and the browser popped up and suggested Applebee's. So I thought, fat chance. And for some reason, the only restaurant chain on earth that's v6 enabled is Applebee's. And I've tried this again and again over the last month, and it does not go away. So, and it's probably an example of the fact that at the bottom of the slide, what I talk about is the woodwork, Akamai, Limelight, Cloudflare, I already said Limelight, AWS and Google Cloud Platform, those guys. Applebee's is probably a client of one of them and has a box check for v6. So it's not even about an individual businesses, of course it isn't about individual businesses enabling v6. It's about their underpinning content distribution handling it, or their cloud stuff. So, and I know that Limelight and Akamai and Cloudflare at least had, like on v6 launch, World IPv6 launch, they said, we're going to turn on v6, or shortly after, we're going to turn on v6 for all our clients today. And so there's some of that going on. And who's accessing content with IPv6? Various Internet 2 members, research organizations, Comcast, Spectrum, both Time Warner and Bright House, Cox, Google Fiber, probably others. It's nothing like exhaustive. In the mobile space, T-Mobile, Verizon, AT&T, probably others. Various large corporate networks like Google, of course. Google is a big ball carrier for IPv6. If you look at the UH Manoa wireless, you see green is V6 and red is IPv4. If you look at it by flows, the traffic on a business day, the V6 is about 30%. If you look by packets, it's about 60%. And if you look at by bits, it's about 50%. So the proportion is actually very conducive to thinking about V6 only networks and IPv4 as a service. And of course, I think the reason why V6 flows seem to be very packet heavy and bit heavy is because you notice that the two big names on the reachable slide were Netflix and YouTube, and those are both very high packet per flow content sources. But wait, there's more. And so John Curran talked about this yesterday. But ARIN constituents who intend to employ V6 transition technologies can pretty easily receive an IPv4 block or between a /28 and a /24 to use for that purpose if they can demonstrate need based on prior assignment use percentage. So if you can't just, hoard a /24 by doing this, but if you're truly in dire straits and you need to look at your next step, buying addresses or whatever, you can start building V6 transition infrastructure, and then you can go to ARIN and said, look at my IPv6 transition infrastructure. Can I have a /24? Although you might want to, talk to them a little bit first. But in NAT 6.4, 256 addresses would support on the order of 16 million NAT mappings or flows at a time. So this came through today. I got this in one of the V6 lists. Europol calls on internet providers to end CGNAT IP address sharing. So the police in Europe are worried that they can no longer distinguish regular citizens from criminals by using IP addresses. And they see CGNAT as a bad thing. And of course, if you're a privacy person, maybe you see it as a good thing. But it is, I just thought it was kind of ironic and indicative that it came through today. If you use single layer NAT, IPv6 or IPv6, I should probably change the slide. If you run single stage NAT, not CGN, you can still fully account for user identity and track DMCA subpoena issues and stuff. If you run CGN, less so. Jeff Harrington's IPv6 security tutorial spoke to doing accounting in an IPv6 network. A lot of people are kind of frustrated by that at the outset, but you can harvest your NDP tables and there's certain things you can do by SNMP. And this is a commonly misunderstood, undersolved problem for many people, but it appears to be doable. So outsourcing IPv4 as a service. I can't really endorse it. It's someone that I've heard of and known about for some time was Lee Howard, who used to be at Time Warner, went out and started Retivia.com. So their flagship offering is IPv4 as a service. You can provide your V6 to your users and send all of their legacy traffic to us over V6 using NAT 6.4, MAP-T, MAP-E, Dual Stack Lite, or 464X Lite. Your network can streamline towards single stack V6 without losing access to legacy V4 content. Essentially, if you build a V6 network, you let the vendor deal with V4. This is several attractive components, among which is that when someone blacklists your NAT pool address, it's the vendor's problem. Because that is the reality of doing, big NAT, is someone blacklists an address and all of a sudden a whole section of your user population can't reach anything. Got about 5.5 minutes. So I'm going to go off on a rant about V6 adoption, but the landscape keeps changing, but the song remains the same, meaning the big content has really stepped up, as I already established. Large residential providers are providing dual stack to homes. Mobile carriers are doing all kinds of wonderful stuff. And T-Mobile does V6 only, just like the SSID in the room. But at the same time, most journalism about V6 is parroting something they were told 5 or 10 years ago. The V6 is going to take a long time. It always lets you off the hook when you read it. Oh, no need to worry about this right now. Well, it's inappropriate for the time, more increasingly, and people need to look towards IPv6 transition in order to survive. Much IPv6 writing is out of date or referring to things that are out of date. This is Google's adoption map. As you can see, it's mostly very light green or white. And so I took 3 months of flow data and I extracted all of the V6 addresses that any of our hosts interacted with during that time. And the top of the frequency histogram, or the left-hand side of the frequency histogram, as in pi form, looks kind of like that. And there's absolutely nothing surprising about that. The US and Ireland, there's big Facebook presence in Ireland and Great Britain and Germany and the Netherlands. I'm a little surprised by Romania after a 3-month sample, but there's probably a reason. But if you look in the long tail, you find things like Barbados. Now, Barbados has 0% connectivity on the Google adoption map and on the Akamai State of the Internet adoption map. And so it's a little surprising to find them down there. And I sussed this out. This is really in Barbados, and it looks like a Facebook cache. All right, so you can read that later. We're running out of time. But then I went and I started working up the long tail, and I kept finding more and more and more small countries, some larger, some smaller, that are also connected. They have a pingable address, most of them handcrafted address. There was one other Facebook cache looking address because it has the letters FACEBOOC in the middle of the address. And they're connected. And my point isn't that the Google map is wrong. My point is the Google map shows you one thing, and you need to slice it a different way to understand that there is latent IPv6 connectivity in all these places. There's a router with an interface with V6 enabled, and if they enable it on a second interface and do some stuff, they could possibly apply one of these V6 solutions that we're talking about. And then, yeah, this is one of those things when you talk through your slide. But I think that it's possible, just possible, that a lot more map can get greener in a short time if IPv6 becomes known as a way to solve problems. So this is a final slide, and it's just a list of measurement stuff. But we have 2 minutes for questions. Anybody got a question? Yes?
Do you have this pie slide also divided by the population of the country?
I don't.
Because of course the US is big.
Yes.
Compared to the Netherlands, you could divide it by population, it might be different.
Yeah. Well, there's a lot about that map. It's so small that it's hard to hover over Barbados, you know? And I would like to get that data and work with it in different forms, but no, you're right. And then when they call it percent adoption, of course, maybe percent normalizes that population difference, but we don't know, or I don't know, so.
Hi, great talk. Thanks very much. You talked about NAT64 for access networks and the experiments and what you're running here. I've just tried a couple of things I expected not to work, but they do. So that's quite reassuring. Have you done any experiments with the sort of V6 only in the data center type environment where you have to do essentially NAT46 or the CIT-DC type of stuff?
You can do what they refer to it as. There is CIT-DC, which is for scale in a data center. And then there's simply sit, or what many people call stateless NAT64. I thought I had a slide for this, but there's stateless NAT64, which is you just essentially map the addresses. So then you make your v4 only presence look like a v6 or available to the v6 internet, and that's much more straightforward.
Yeah. I was thinking running v6 only in the data center and still presenting a v4 connectivity to it.
Oh well, yeah. Actually, I think it doesn't matter because actually stateless sit is a lot more bidirectional by nature. So see, there's another case. Now I need to iterate that, but I think it's totally possible.
Okay.
Yeah. Anything else?